we're trying to find ways to measure radiation using UAVs or measure hazmat gases or using optical gas imaging to locate leaks in pipelines or of methane, things of that nature. So we're trying to take our existing technology and make it so that it's more form-fitted and suitable for UAS operations.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 194. How are thermal cameras used in the drone industry? For that question, we turn to Randall Warnas of Flir Systems. Flir designs, develops, manufactures, markets, and distributes thermal imaging technologies that protect and save lives, promote efficiency, and innovate consumer-facing technologies. At Flir, Randall runs the company's sUAS global business and has a unique perspective of the drone industry. From pioneering drone retail in 2014, he went on to develop the initial stages and foundation of DJI's enterprise business. Now working for Flir, he has engaged with tens of thousands of end users in both the consumer and commercial space. In this edition of the Drone Radio Show, Randall introduces us to Flir Systems, their thermal drone technology, and he discusses some of the use cases for thermal imaging. But before we hear from Randall, I want to thank those of you who are supporting my funding campaign. Now you have the option of making a one-time donation in any amount by going to droneradioshow.com/donate. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. And if you'd like to make a monthly contribution, you can still go to patreon.com/droneradioshow. So let's learn how thermal imaging cameras are used in the drone industry with Randall Warnas of Flir Systems. Let's pick up the interview where I asked Randall to introduce himself.
So my name is Randall Warnas, and I run Flir's sUAS business. Basically, I work with manufacturers of drone technology around the world in integrating thermal imaging sensors and payloads onto their airframes, as well as working with end users of this technology to know how to use thermal correctly and get the most out of these sensor payloads on airframes, and then enabling software developers to put thermal into their systems so that they can do things like 3D modeling or orthomosaics and things of that nature. So my position within Flir is to enable thermal on small UAS in every way possible.
Randall, tell us about Flir Systems.
We're a 40-year-old company. We've been making primarily thermal imaging technology for quite a while and are leaders in that space globally. And in the early days, thermal imagers were quite large and generally for mostly either scientific research or military purposes. And over time, the technology has been improved and miniaturized, and the price has been reduced to the point that we enable the world to use what we call the sixth sense, which is looking in that infrared band and making sense of radiation coming off of every object around us in the world, turning that into temperature data, something more digestible, and making assessments on the longevity of infrastructure or locating people, which is, two of the primary uses of thermal imaging technology. But then we're seeing a lot of creative users behind drone technology finding ways to use thermal imaging in very unique and compelling ways, and in some cases, creating entire industry standards behind it.
In terms of the drone industry, how prevalent are thermal sensors?
My kind of coined phrase is that thermal imaging is the most promising payload for UAS outside of the RGB camera. So there's probably as many thermal imaging cameras as all the other kinds of sensors used on drones outside of just regular RGB cameras combined, maybe even double or triple that. They're quite plentiful just because the use cases are already known, because this technology has been used for a long time from aerial platforms, just not small UAS. And the size of the market is constantly growing as we're seeing more budgets opening up for drone technology. When you're looking at professional uses of drones, you're seeing that the platform is almost an afterthought, and really it's what can you collect the data with? And for public safety entities, utilities, oil and gas, solar inspections, wildlife preservation, all of these areas are being impacted positively by thermal. And as we're seeing more adoption and more success stories being shared around the industry, we're finding that the market is increasing every quarter.
Can you talk about some of the ways that thermal sensors are used?
I mean, like I said, some of the most prevalent are going to be public safety and utilities, because in utilities, there's a lot of data that's extracted by temperature, meaning that if there's a normal operating temperature of a transistor on top of a power pole, if you can measure the temperature of it without contact, without putting a person in harm's way, and do it really quickly by flying up in the air and running down a line of poles that you can see from the ground, that you can look for that temperature measurement and see if it falls within the normal operating parameters, and then only send people up those power poles to do further inspection work or repairs when there's an actual problem. And that reduces the amount of instances that you're putting a person in close proximity to high voltage power lines. Solar inspection is another big thing where it seems pretty compelling. If you look at a solar field, you don't know if it's working properly. The only way to know is to have instrumentation on the back or to do inspections with thermal imagers. So putting one in the air and being able to do things like orthomosaics that look for an entire solar farm, you can make assessments quite easily. Solar inspections are generally done every 6 months because they're so time consuming and they're actually quite inaccurate, where with drone technology, you can do an entire field depending on the size, and certainly a day, sometimes in a matter of hours. But then on the public safety side, you could just imagine that seeing people or seeing subjects of interest in darkness, if they're putting off a heat signature, is really compelling for them. I know that a Flir camera was used to locate the Boston bomber hiding under a tarp on a boat in a neighborhood, which you wouldn't be able to do that without that technology. And those are the same kind of principles we're putting to the small UAS.
Does it require any special training to understand how to interpret the various colors and the heat signatures?
So I think that you're asking a really good question. And the first answer to that comes to my mind is that no, there's not any real special training, but experience is always going to make you better at using any technology. So with thermal imaging, you talked about the colorization of images. Those colors are not necessarily representative of a specific temperature, but what they are is they're representative of how hot or cold something is relative to the other things within the scene. So as long as you are able to frame a shot with good contrast of objects within the given time when you're looking at a picture, you'll be able to extract what things are hot and what things are cold. That's very easy for public safety to do since they're not particularly interested in the exact temperature of those objects. But when we're talking about utilities, there are things like emissivity, which is in short the opposite of reflectivity. It's how much something absorbs and doesn't reflect other things around it. And the emissivity of objects and being able to put in the right inputs into the camera will give you better temperature readings, more accuracy. And that's where, professional users in the utility space will want to have a good background in that, where there's other applications like solar inspections or roof inspections where it's not as nuanced.
Public safety organizations really seem to be jumping into thermal imaging. What are some of the reasons for this?
I mean, I don't want to overstate the importance of FLIR or thermal imaging sensors to public safety, but really the drone is significantly improved or more useful to these entities when they can have thermal on there, not only because night operations are generally where a lot of these first responder type missions happen, search and rescue things, and also bad guys running from law enforcement. Those are things that it enables the drone to be useful for a longer period of time. And it also just gives you another perspective of when you are looking for a subject. Now, accident recreation and things like that are going to continue to be done with RGB cameras and 3D modeling and things of that nature. But when you are looking for a subject, especially a person, there's no better tool out there than a thermal imaging camera, even an RGB camera in the middle of the day. So we are seeing the demand for thermal, especially from public safety, on the rise. And as departments like Los Angeles Fire Department, New York Fire Department, New York Police Department all make their announcements of the technology that they're using and that it includes thermal imaging cameras, I think that that's really encouraging other departments to start exploring the ones that happen.
For an organization interested in thermal imaging, what equipment do they need?
So definitely a different camera, and we do make both drone agnostic cameras as well as plug-and-play systems, or our sensors are integrated into pretty much every major airframe in the world. So there's generally a thermal imaging option, and usually those will be FLIR cameras. 90 plus will be FLIR cameras. But let's say someone has a Phantom, DJI Phantom airframe. There's no plug-and-play option for that, so they would use a drone-agnostic camera like the FLIR View Pro, which is maybe this a little bit larger than a GoPro, let's say, and do the integration onto that airframe. Now, there's no extra software needed to capture this, but it is kind of an integration process. So there is a downlink system that would be required for this do-it-yourself type process, and the ability to control and take photos while in flight, things of that nature need to be programmed in. We generally want people to work through our reseller channel for those integration projects just because they have done so many of them and can make it much cleaner and easier. But we also make plug-and-play products like the ZenMuse XT and ZenMuse XT2 through DJI that are plug-and-play with some of their airframes. So basically, it takes the guessing or the thinking work out of it and the ease of use you would expect from a DJI product. And we have similar products with other manufacturers. Just FLIR is not as involved in bringing those to market.
What about a house fire or even a wildfire? I've heard that thermal imaging can play a role in these situations, but how do they work?
If you imagine that a house fire, a structural fire, has a lot of smoke billowing over the roof, and you can't really see through it with the naked eye, and definitely with an RGB camera would be the same. Thermal imaging actually penetrates or is unaffected by obscurance like smoke. So you're able to see hot spots on a roof, even if it's covered in smoke. You could also see people if they're inside a smoky window, that's possible. And then for wildland fires, you're able to see the perimeter of that fire and able to measure the reduction. Also find hot spots where you can basically point at to the crews with hoses that are, or anything that's dropping water, and be able to more accurately place that water based off of what you're able to see from the sky.
What about situations involving hazardous materials or chemicals?
FLIR has technology that is specific to hazmat materials, and those are things that we're exploring for the upcoming year in bringing to a more clean solution for small UAS. But when you're using a thermal imaging camera like the long wave cameras that I was talking about before, you're able to see things like tank levels. So let's imagine that you pull up on a scene where there's a tanker that rolled over. You can see how much liquid is in that tank. And also with our MSX technology, which basically blends the thermal and an RGB image together, you're able to see things like placards that would tell you what kind of chemical is inside the tank with a single image, rather than flying a thermal image and an RGB image separately to get that data. So we're trying to make it as easy as possible for our public safety users to get as much indication of what they're dealing with in the shortest amount of time.
What have been some of the more creative ways that you've seen people use the FLIR products?
So one of my go-tos is a project that we were working on with Ocean Alliance, which is based in Massachusetts. And what they do is study whales. And I think maybe some of your listeners, or many of your listeners, may have heard of the Snotbot. The Snotbot is a drone with a petri dish on the top of it. And as whales fed out that plume of stuff from their blowhole, it captures it onto the petri dish, and they're able to take those samples back and study them. Well, Dr. Ian Kerr, who is the head of Ocean Alliance, had this idea that why can't we use a thermal imaging drone, fly over these whales, look straight down, and get the measurement of the blowhole itself? Now, to date, science has never provided a reliable or easy way to get the temperature of a whale's inside, unless it's dead or unless it's, sedated in some way. But just a normal, living, functioning whale in the wild, to be able to get the temperature of that blowhole was next to impossible. Well, using thermal imaging technology, in July, we went out and got the first temperature reading of a whale's blowhole ever. And that organization is replicating this over and over throughout the world and many different species of whales to determine, is that data useful in telling us whether whales are sick or pregnant or anything else about these species. So that's a really creative and unique way that this technology has moved forward. And there's also things like in wildlife, there's a lot of exploration. Several zoos around the United States are using this technology to monitor nesting animals in the canopies of trees in South and Central America, which is really interesting, some of the data that comes back. The University of Exeter in the United Kingdom is doing assessments of butterfly species, because these butterflies will spin this silk web around hot plants. And rather than try to walk through this field and count them, they can fly above them. And the heat signature is so different than the subjects around them that they basically glow. And they're able to estimate populations based off of that. So those are just some of the interesting ways that I've seen this technology used recently.
Now, here in Florida, primarily in the Everglades, there's a large population of pythons and boa constrictors, which have become a problem for the natural ecosystem. Could a thermal imager on a drone be able to differentiate a snake from the surrounding environment?
The Everglades obviously has a lot of overgrowth as far as foliage and things of that nature that the snakes would be kind of slithering through. And if you're able to see a snake's body or head exposed to the sun long enough, it would start radiating that heat. I think that with cold-blooded animals, it's a little bit more difficult to see than warm-blooded animals. But, I mean, in theory, if they're big enough, sure, or if you're flying close enough. The only thing is that if they're truly covered by very thick plant matter, that you would have a hard time seeing them. But even small pieces of very hot material around a lot of cold leaves would pop out, and then you would know there's at least something there. Whether you could differentiate if it's a snake or not would depend on how much is exposed.
From your vantage point inside of Flir, can you tell us what we might see in the future in the way of thermal imaging and drones?
The cameras that most people are familiar with in thermal are long-wave infrared cameras, and those have a very specific use case, and they're more the general use cases that we've been talking about. But we also have a ton of technology that has been developed by Flir over many years that we're trying to find the best way to bring that to market. And whether they're currently too large or too expensive or just not fit for small UAS applications today, we're trying to find ways to measure radiation using UAVs or measure hazmat gases like we were talking about, or using optical gas imaging to locate leaks in pipelines or of methane, things of that nature. So we're trying to take our existing technology and make it so that it's more form-fitted and suitable for UAS operations. Now, that's not without its challenges. We're talking about measuring things from the air with a lot of atmosphere and things in between it, and there's some fine-tuning that needs to be done there. And we also need a market to sell to, because if we're not going to necessarily be thrilled about making a product we don't know people want. So we do ask people to be vocal about what they would like to see from Flir, since we are the leaders in this sensing technology, and tell us what we could bring out to market to solve some of these industrial needs.
Most of the people I interview are entrepreneurs with a startup and a new technology. But Flir is an exception in that it's an established company applying a proven technology to a new market segment. How does that affect how the company approaches the marketplace?
Well, because we're a publicly traded company, we do have, our minds always set on our shareholders and keeping our promises to those folks that are making our growth possible. So if you imagine Toyota, that has made automotives for a long time, if someone within their organization said, well, we know how to make motors, we know how to make drivetrains, we know how to make this stuff, why don't we start making boats? Someone might have to step back and say, is that really the best use of our time? Is that really, what people want? Are we going to be competitive in that market? Now, because UAS is so new, and because we've worked with military UAS technology for a really long time and putting thermal sensors on it, it did make sense. But there is still this, it's not our bread and butter. It's not going to make or break whether we're able to achieve our goals as a company for the short term. But long term, we see it as a way that we can differentiate ourselves, diversify our portfolio, keep on the cutting edge of technology, be involved in this space. And I think that Flir, because we've worked with military so long, it has very formal roots. It's very regimented in how we've used this technology previously. But as we put things out to the consumer market with the Flir One, which goes into the iPhone and Android devices, when we've done things like handheld scopes for hunters and things of that nature that are maybe expose a broader group other than just military and law enforcement personnel to thermal, I think that we want to stay on this, we're a technology company. We want to be seen as a innovative company and not just a military contract company.
What's it been like for you personally working in the drone industry?
It's been a ride. It's been a really enjoyable ride, but my first entrance into the drone space was in 2014. Me and two business partners started a company doing drone retail, and we were the first brick and mortar drone retail store in the world and grew quite quickly. In 9 months, we went from one location in Las Vegas, Nevada to 15 around North America, including 2 in Canada, 1 in Hawaii, and basically we saw that there was a reason to grow a big footprint in this space really quickly. We were one of the largest resellers of DJI technology in the world. At one point in the early days, things were okay to be on Amazon and eBay. We led in both categories at one point. So going from that retail background, I then joined DJI and with two colleagues in China, started the foundation of DJI Enterprise. So worked with Fortune 500 companies and dozens, if not hundreds, of public safety entities in starting up the early drone programs of these early adopters of DJI technology. So now as you see what DJI Enterprise is today, that was all laid by just some really interesting people that said, yeah, we see a future in this drone technology. And now there's many products. When I was there was very few. So got to get a very privileged perspective of how the drone industry was growing, working with the unarguable leader of the drone industry. And then now working with Flir, it unlocks me to work with all manufacturers. And because we don't have real close competitors, it just makes it so that I can have a closer view on all the things that are going on within the drone world, continuing our relationship with DJI as well.
Are the brick and mortar stores still in business?
There's one left. It's kind of a funny story in that, and I don't know how much you or your listeners care about it, but drone retail at the start was amazing because margins were there and there weren't a ton of places that you could go and buy a drone, let alone walk into a store and see one and fly one and talk to someone that's knowledgeable about it. When I left to go to DJI, I left an organization behind with 15 locations and 60 employees that were quite widespread. And I was the one that was interacting mostly with our employees and our teams. So I did leave that in my business partner's hands. And although they're really smart guys and have their own skill set, running an organization like that in the ever-changing market that is the drone industry, it just didn't end up working out long-term. So all of those locations shut down, unfortunately, except for our location in Dallas is still being run by my good pal, Don Garland, and they're still doing quite well.
Was there anything that you learned through that experience that you consider to be a key lesson within the drone industry?
Absolutely. The first is that drone market research or market reports are not something that I would personally rely on. I think that no matter who publishes it, whether it's a very large publication or smaller publications that are close to the drone industry, we all have something to do with the success of DJI, being whatever percent you want to throw out there, whether it's 70 to 90% of the drone industry is driven by one company as far as revenue goes. And I know, as working for that company, they don't share their numbers with the world. So for someone to project out what the drone industry is doing, it's very difficult to have any trust in these publications based off of the fact that they don't have the numbers of the largest manufacturer, as well as DJI sells, say, 1 million samples in a year. And a lot of them are sold through Best Buy and through the Apple Store and through B&H. Well, that shows up as a consumer sale. But let's say that the fire department that's wanting to use this technology bought it from a B&H or from a Best Buy. That's not showing up as an enterprise or an industrial sale. That's showing up as a consumer sale. And because DJI up until recently didn't have airframes that were differentiated from their consumer products, there was no way to know what industries were really growing through their scope. And I think that that's one reason that they put out things like the Mavic 2 Enterprise, is so that they can say, no, these are enterprise users using this technology. Even though it's a consumer-looking product, it's differentiated by name and maybe some other features so that we know that the enterprise use of drones are growing, the industrial use of drones is growing, not just sales figures that all show up as consumers. So I think that when I started this drone company years ago, we thought it was a land grab. And, we read reports that agriculture was going to take off and it was going to be a $60 billion business by 2018, 2019. Now, looking back, we as a drone industry just need to take a deep breath and realize that it hasn't hit yet. We haven't reached this drone explosion where everyone's using them in a really big way. We're starting to see really exciting things happen. But unless you're willing to brace out the next few years and, maybe take some hits or maybe have some ups and downs, maybe this isn't the industry for you. And I think that we've seen consolidation within the drone industry this year, some very public, some a little more, quiet. But we do know that if you're not putting something out in the market today, and if you've made expectations from your investors or others that this is a bigger industry than it is, you're going to have some problems. And I think that if I'm an entrepreneur in this space right now, I'm trying to keep myself very level on what to expect from this industry.
So building on that, what's your prediction for what we can expect?
So my crystal ball is based off of two correlated features. One is how many times in the 2019 will we see a large entity like the New York Police Department or like pick your Fortune 100 company comes out and says, we're using drones and we're finding that there's efficiencies in XYZ, whether it's efficiencies in the inspections or it's safety precautions that we're taking. So in mining or large manufacturing and construction, in insurance, the more that you see the guy from State Farm come out and say, we're using drones and it's, making your damage assessment even faster. Those are big wins for the industry. And the more that there's this public sharing of using this technology, the more likely we're going to secure its longevity and encourage really smart companies in Silicon Valley and elsewhere around the world to invest in building tools, whether it's artificial intelligence and machine vision or anomaly detection, things of that nature for this industry. And the second part is that we rely on regulation. And the FAA has done amazing things over the last 4 years, going from Wild Wild West to the 333 exemptions to Part 107, which has enabled a whole new fleet of pilots that can be deployed out into the world. But we still need the ability to do things like beyond visual line of sight flights and flying over people to do big scale improvements in the way that we function as human beings, like in utility inspections, oil and gas inspections, because right now so much is done manually on foot or on ground vehicles. And we know that the efficiencies of drones are cheaper and sometimes more reliable. And we just need to have the government say, yes, you can do this, start promoting people to take the risk and start building technology around it.
Randall, is there anything that we missed that we should talk about?
The key thing for me right now is that collaboration is not plentiful in this industry. I think that everyone feels like they're doing something for the first time and they want to keep that secret, or that they're just not as easy to work with as you might see in other industries. And I think that there's so much we could be learning from each other. And whether there's a dollar sign in the short term attached to it or not, I think that we should encourage the industry to do more collaboration. And when we're at places like different drone shows throughout the year, that we're not looking at everyone as a strict competitor, but we're all preserving the same game, which is the longevity of UAS technology in the hands of people other than military and public safety. And if we can't secure that, the industry is likely to evaporate. So we need to find ways to responsibly use this technology, present this technology, and talk about the cool things we're doing so that it grows the number of people that are at least acknowledging that this technology is of value and here to stay, because otherwise they treat it as a game, and I don't think that's good for the industry.
Why do you feel that there's a barrier to collaboration?
Well, I think it's the competitive nature of capitalism in general. I think that part of that is DJI's stronghold on the industry, and Flir is probably the truest partner with DJI that there is on the planet, because we have formal agreements, we have formal products that we've engineered together, and I think that that's pretty unique. But I also think that to be able to interface with DJI ecosystem is great, but to be able to stand with the company as a partner is better, and to be able to have that backing is just not plentiful with the industry. And I think that when we're talking about smaller airframe manufacturers, it's all about competing in price or being the first to put something novel out, which I don't think is unique to this industry. There's more people that have access to that. It's only going to grow the industry, not shrink it. And I think that that's something that's a little bit backward. And
for my final question, Randall, what message would you like to leave regarding Flir and its role in the drone industry?
The first is we're open to work with anyone and everyone and make as much use out of aerial platforms as possible. Consider ourselves very forward-thinking and leaders in drone technology. We have one of the great minds in the drone industry, Jeff, who's one of our senior VPs of product strategy. He saw drone technology being important decades ago and really started investing Flir in the last 4 or 5 years in a big way. And I think that if there's drone either super end users that want to get deeper in this technology and do more, or if there's manufacturers or software companies that aren't working with us already, that they should reach out, because we want to expose the great things that everyone is doing, whether it's thermal or not.
That's it for episode 194 of the Drone Radio Show. I hope you enjoyed hearing from Randall Warnas of Flir. I want to thank Randall for taking the time to speak with me. If you want to learn more about Flir or want to connect with Randall, check out the webpage at flir.com. And if you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate or patreon.com/droneradioshow. Thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.